Hi guys, we had a couple of questions from section 3.1. Now section 3.1, of course, we covered that before the spring break, so obviously you should have some lecture on that. But a couple of problems, which is actually good because if you remember in section 3.1, we talked about two different forms of a quadratic function, the standard form and general form. So let me just remind you real quick. Again, this is section 3.1. So the standard form was f of x equals a times x minus h squared plus k. Now the significance of that, if you remember, was that if the function is in a standard form, the vertex, which is pretty much the most important information about the function, is already given because the h and k will provide you with the vertex. So once you have your standard form, you can find the vertex as just basically the order per h comma k. Okay, but you have to have exactly this form. And if you remember the sign of a, the number in front here, will tell you how because the graph is going to be a parabola. As you remember, the graph of every quadratic function is a parabola. So you have something like that. Of course, it could also open downward. And that's what the A determines, right? So if A is positive, your parabola will always open up. If A is negative, it will always open down, okay? Now, in the problem that we're going to look at, the first one is, I think the student wanted to know number 26. So the good thing about 26 is that it's already in a standard form. So actually almost a standard form. So let me write the function f of x equals x minus 5 square minus 4. So, sorry. So as you can see, this function almost identically matches the standard form. The only problem is, of course, it's supposed to have a plus, some number at the end. Here you have minus, but as we have done that many times, we can rewrite that as plus minus 4. Or plus, sorry, negative 4. So now you have the perfect match. Of course, your A would be 1 because there's nothing in front, which means there's always 1 in front. So it is positive. So when you graph this, your graph is going to open upward, your parabola. And the vertex, the first thing they want to know, what's the vertex? Well, because your function now is in a standard form, as you know, the rule says h comma k. So your h would be 5, and your k, which is what comes after the plus, will be negative 4. So now you have your vertex, okay? And you know it's going to open up because the number in front is positive 1. So it's going to open upward, your parabola. So you already know basically what the graph looks like. But they want to know the axis, which we'll talk about that in a minute, the domain, range, and also where is it increasing, decreasing. Okay, so I'm going to go ahead and leave the vertex here because that's all we need to know really to answer the rest of the question. So let's go ahead and actually, if you remember in class, I always told you that to go ahead and graph it at this stage. So the graph can help you with some of the other questions we have to answer. So 5, let's say here is 5. And then y is negative 4. Let's say here is negative 4. So and your parabola is going to open up. So this is pretty much the graph of your function. So the axis, as you remember, that's the vertical line that crosses through your vertex. Of course, if it's going to be vertical, it's going to be x equals to a constant, and the constant is always the place it's going to cross, right? Which in this case is going to be 5. So x equals to 5 is the equation for your axis. Domain of every quadratic function is all real numbers. The range depends on the function. So as you can see, this range, of course, are always the y value. So this function starts from negative 4 and goes up, which is all the numbers greater than or equal to negative 4. So we write that in interval notation, bracket negative 4 to infinity. Where the graph goes down, the function is decreasing. When it goes up, is increasing. So to the left of 5 will always be decreasing. So I'm going to put DEC for decreasing. And it will be the interval negative infinity all the way to 5. And then once you get to 5, it starts going up, and hence it becomes increasing. So we say increasing on 5 to infinity. Okay, so that answers all the questions for this was problem number 26 in section 3.1, okay? Now, the next one the student asking is 29. Same question, we have to answer all the same question, except that function is in general form. So let me quickly remind you of how we find the vertex for the general form, because that's the only difference between a standard versus general is how you find the vertex, okay? So let me go ahead and take this off. So now, in number 29, we're given the function f of x equals x squared minus 2x plus 3. So if you remember from your notes from the section 3.1, because this is in general form, the vertex is going to be given by the formula negative b over 2a. That will be your x coordinate, and of course f of that, which is always your y value, f of b over negative b over 2a. So this is your vertex. It's known as vertex formula. Now remember, the a is always the number in front of x squared. So in this case, your a is 1. The b is always the number in front of the x. That will be negative 2. So really all you have to do is just go to plug into the formula. So let's find the x coordinate of the vertex, which is negative b over 2a. In this case, that will be negative over negative 2 over 2 times 1, because your a is 1. The two negatives cancel, and 2 over 2 becomes 1. So your x coordinate of your vertex is already determined to be number 1. Now to find the y, as you know, y is always f of x. So it will be f of the same number, negative b over 2a. And of course, in this case, we found that to be 1. So we have to find f of 1, which of course we do by going back to original function, replacing all the x's with 1. So that's 1 squared minus 2 times 1 plus 3. That's 1. 1 minus 2 is negative 1 plus 3, which is number 2. Okay, so now the vertex has been found. So 1, 2 is your vertex, okay? And now, of course, it's going to open up again because the a, remember your a is 1 again, which is positive. So it will open upward. Okay, let me go ahead and graph it, and then I'll answer the rest of the question. So I just need the vertex and how it opens. So again, vertex at 1, 2 opens upward. So your axis is going to be, in this case, the vertical line goes through 1, so x equals to 1. Domain, again, all real numbers. The range starts from 2, goes up, so it will be all numbers greater or equal to 2, so bracket 2 to infinity. And of course, when the graph goes down, the function is decreasing, so it will be decreasing all the way to 1, decreasing on negative infinity to 1, and then once it gets to 1, it goes up, so it becomes increasing on 1 to infinity. Okay, and they're all the answers for problem 29. I hope that helps.